Okay, so we're working on division of radical expressions. And we have radical symbols, and inside them we have fractions. And what I want to stress is the importance of order of operations here. We know our please excuse my dear Aunt Sally is the order we proceed when we're working with an algebra expression. P means please do what's inside the grouping symbol first. And a radical is a grouping symbol. So when I look at this expression, cube root of 40 divided by 5, my gut says do what's inside, which is 40 divided by 5. And if I do that, I would be left with the cube root of 8. Now, could I leave that as the final answer? Absolutely not. Because if I go to my cube root list, 8 is a perfect cube, and I should know the cube root of 8 is 2. Now, there is another way to proceed and work this expression and get the same result, and you're still mathematically correct. Another way to work this expression is to understand this cube root belongs both to the numerator and the denominator. So I could rewrite this as the cube root of 40 over the cube root of 5. And once I rewrite it, then I could do the root part first. I could say, okay, let's simplify the cube root of 40, which means I need a perfect cube number in 40. So again, if I go to my perfect cube list, which of these numbers is a factor of 40? Very good, it's 8. So I can rewrite this numerator as the cube root of 8 times 5. The denominator is a cube root of 5. Well, 5 is not a perfect cube, nor is there any perfect cube number in 5. 5 is just 1 times 5. So we know we can't simplify the cube root of 5, so we'll just leave it. So now we have in the numerator the cube root of 8 times 5 divided by the cube root of 5. Well, now we can keep working the numerator. We can keep simplifying. The cube root of 8 is the number 2. It comes out. We cannot cube root 5, so it stays inside our radical sign. So now we have 2 cube roots of 5 divided by 2 cube roots of 5. Because the 2 is connected by multiplication, we're allowed to do division, and we've talked about this in previous modules. Dividing the same term by itself makes a 1. It cancels out because 1 times 2 would be 2. So did we reach the same result? Yes, we have the same quotient. Now you tell me, which method was easier? Was it easier to do the dividing first, reducing the fraction, or was it easier to do the rooting first? And if you all agree, reducing the fraction first makes more sense because it's less work for you. All right, let's look at another expression. Square root of 2x to the 5th divided by 32x. So we have a fraction inside a square root. Again, what I would do first is follow order of operations, and I would do the inside. I would do the division. These are monomials. They're connected by multiplication. 2 and 32 divide. Their greatest common factor is 2. So 2 divided by 2 is 1. 32 divided by 2 is 16. 16 goes in the denominator because that's where the bigger value is. Now we're going to divide our variables. X to the 5th divided by x to the 1st would be x to the 4th. 5 minus 1 is 4. That would go in the numerator because that's where more x's are. So now we have in this root symbol, our square root symbol, we have x to the 4th over 16. So we reduced our fraction first. Now we'll share our square root symbol. We're doing the square root of x to the 4th, and we're doing the square root of 16. Both of these terms are perfect squares. X has an even exponent, so it's a perfect square. What times itself is x to the 4th? X squared. 16 is a perfect square. What times itself is 16? That's 4. One way to write that answer is x squared divided by 4. But that's not a monomial. To be a monomial, it has to be connected by multiplication. So dividing by 4 means you multiplied by 1/4. There's an invisible coefficient of 1 here. 1 over 4 is 1/4. And then you'd put the x squared in the middle of the fraction bar. So writing x squared divided by 4 is not a monomial. It's not connected by multiplication. Writing 1/4 x squared is a monomial. And both of these are acceptable expressions. We still have more division to come. See you the next module.